sine and cosine. Like I just said, the sine and the cosine graphs are going to be on an xy plane, but the x is going to represent the angle measure. The y is going to represent whatever the sine or cosine value is at that point. So we'll start with the sine graph. We're going to do that one first. So we're going to go by pi over 2. So we're going to mark it off using radians. Pi over 2, and then pi, and then 3 pi over 2, and then 2 pi. We'll also go backwards. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. The biggest number that y is, or sine is our y on our unit circle. The largest number it gets to be is 1. Smallest number it gets to be is -1. So we're just going to be bouncing between 1 and -1. We're not going to get any bigger on our regular sine graph. The highest is 1 for the y value, lowest is -1. Okay, I'll let y'all get those marked off. And we're going to start and just work our way around our unit circle. Sine is the y value, right? It goes cosine and then sine. So we're going to look at each of these angle measures. And whatever the y value is, we're going to plot that on our graph. So if I look at my first one, I'm at 0 degrees or 0 radians. What is the sine when I'm at 0 radians? At 0 radians, my sine is 0, right? My y value is 0. So I'm going to plot 0 when I'm at 0 radians. Go to pi over 2. Pi over 2 is here. What is the y value at pi over 2? It is 1. So when you're at pi over 2, you're going to plot at 1. Okay. Now we'll go to pi. Here's pi. What's the y value at pi? 0. So pi, we're going to plot 0 for the y value. Now we'll go to 3 pi over 2. 3 pi over 2, what's the y value? -1. 3 pi over 2, we're at -1. Then we'll go back to 2 pi. What's the y value at 2 pi? That is 0. So here we go. And I did the root 2 over 2 just so we could see what's happening in between here. If you didn't know, if you've never done the decimal approximation of root 2 over 2, it's 0.7. So 0.7 is what root 2 over 2 would be. So at pi over 4, we're kind of like here, and then here, and then here. Those are my halfway points. They're kind of at 0.7, -0.7. You don't have to sketch these when you're drawing your regular one. You just have to do these parts. But this is going to kind of let us know how it curves. So can you visualize if you connected these points that you would have a curve that went in between them? I'll show you what it looks like. Kind of goes up and then down and then up. And because it's a circle, what do you think is going to happen once we get to here? We went around. We're just going to start over. So it just continues in this same pattern. So we went around the circle one time. This is one time around the circle. And then you just continue doing that forever and ever and ever and ever. I mean, you don't have to draw it, but it does go on forever and ever. Let's double check and going backwards around the circle just to make sure that we're good. -pi over 2. is -1. Negative pi is 0. -3 pi over 2 is 1. And -2 pi is 0. Okay. But the part of the sine graph that we need to know the most is the part from 0 to 2 pi. This part here, that we go up to 1, to pi, to -1, and back to 2 pi. Sine starts at 0 and ends at 0. Okay. The beginning and the end, how long does it take for us to start and finish one of our cycles? To go from here to here, how many radians is that? That is 2 pi, right? So 2 pi radians. 4 of our little tick marks, but it's 2 pi radians. And after 2 pi, it repeats again. So at 4 pi, it would be the same, 6 pi, 8 pi, 10 pi, all the way around, okay? So one of these rotations or cycles, or from start to finish, is called a period. So a regular sine graph has a period of 2 pi, which means that it starts over every 2 pi, because it goes around the circle and begins again, and begins again. Okay, so that is our sine graph. We're going to take it and shift it around. We're going to stretch it, compress it, do all the things that we do for all of our graphs. That's the point of what we're doing today. Now we'll do cosine and see the difference between the two of them. So this way, when we're working our way around the circle, cosine is which value, the x or the y? It's the x. So we're going to be looking at the x from the ordered pair, and that's what we'll plot. Okay. So when you are at 0 radians, what is the x value? Bless you. When you're at 0 radians, the x value is 1. So we're going to plot a 1. When you're at pi over 2, the x value is 0. When you're at pi, what's the x value? -1. Good. When you're at 3 pi over 2, the x value is 0. And back to 2 pi, the x value again is 1. Okay, and we can follow this same pattern. It happens that it goes this way as well. The other. So we start at 0, we finish at 0, from 0 to 2 pi, then it starts over. So for the cosine, this is our 1 period. At the beginning, it's at 1 and it finishes at 1. It goes down to -1 and comes back up for our first period of cosine. What's the same with sine and cosine? What's similar about them? If you saw those two graphs, what would you say? These things look the same because
the way that is forming, like when it's just the opposite way.
They're both just waves, right? These are called sine waves for that, so they're both waves.
Can you scroll up a little more?
Scroll up a little more? Yeah. There you go. So they're both sine waves. Oh, the other one. It just says sine up there. There you go. So they're both sine waves. If you took the cosine and you moved it over, would it match up with the sine exactly? If you just took it and shifted it? Yeah, we would just have to shift it over how much? I think it would just be pi over 2. Yeah, one of those little blocks, which is pi over 2. If you shift it over that much, they'd be the exact same graph. Sine and cosine are always pi over 2 apart from each other. For that, the difference is, though, is if you were on the y-axis, at sine, you're at 0 on the y-axis, and cosine, you're at 1. So that's the main way that you can tell these apart, that sine starts at the origin. All right, sine starts at the origin. Cosine starts at 1. Starts and ends at 1. Sine starts and ends at 0 there. Okay, so that's our sine. This is our cosine graph. So what we're going to do now is we are going to stretch them. We're going to compress them vertically. We're going to shift them vertically. We're going to shift them horizontally, and we will stretch and compress horizontally. But they have weird names because, of course, we couldn't just say stretch and compress. They're going to give us fancy names because they have to do with sine waves, and I think it's all sciencey stuff. That. So we'll start with the first type of problems. They're called, it's an amplitude change. When you think of amplitude, what do you think of? Loud, because you're thinking of an amp or music. Yeah, amplitude with these waves are the same with those sound waves. If we make our sound waves bigger, they're going to be louder. I'm saying that. I hope that's the truth. But the waves are going to get stretched out. Okay. So when we have an amplitude change, we are going to change the height of our sine waves. And if we have a number in the front of sine or cosine, just that's multiplied, that's going to be our amplitude. Okay, so we'll just do 2 examples of this. Just some real quick ones, and then we'll move on to some others. Just going to do the first period for these, just so I don't have to draw all the marks out every time. All right, if I had 3 sine theta, we are multiplying the y values by 3. So instead of going from -1 to 1, we're going to go from -3 to 3. But the shape is going to be the exact same as before. But instead of hitting 1 and -1, we'll hit 3 and -3. Okay, so sine starts at the origin, right? Sine starts at the origin, goes up to 1, but in this case, we're going to go up to 3. Back to the x-axis, down to -3, back to the x-axis again.
Is that it?
Amplitude of 3. Yep.
Okay, so I'm sorry, what did you say when you said in this I'm sorry, I'm stuttering, I'm sorry. You had said a statement. You was like 3 would be the amplitude?
Yeah,
Okay.
amplitude is 3. If it's multiplied in the front here, that's going to be our change, like a multiply of the y values, which is going to be called our amplitude. So the amplitude is 3. The minimum value, if they ask, would be -3. The maximum would be 3. What's the difference between the minimum and maximum value on this? The difference between the min and the max, how far apart are they?
3.
From the very bottom to the very top. To go from the very, very bottom to the very top, and that is 6, right? They're 6 apart. So if someone asks for the height of this sine wave, the height of it would be 6. They don't really ask that much, but I have seen it on the ACT before. They asked like what the difference was between the highest and lowest. So wanted you to see that. All right, on our second one, our amplitude is 1/2, which means that where we would normally go up to 1, instead we're just going up to 1/2. So cosine normally starts at 1, but for this one, we're going to start at 1/2. Then we hit 0, then -1/2, then 0, then 1/2.
Is this all we're learning, or is there more?
We're going to, this is just the vertical stretch. We're going to do horizontal stretch and compress. We're going to do vertical and horizontal shifts. So after, I mean, those 3 things, that's all. What do you think would happen if there was a negative in front of the number?
You would start on the y-axis at the bottom?
Yeah, it would flip it over. The whole thing gets flipped. So for a sine graph, you would start going downwards first. For a cosine, you would start here and then go up. So if there's a negative, your graph is just flipped over. So amplitude is also a vertical stretch. That's what we've always called it before. Or compression. All right, if you have a number that's in front of your theta, so it's with your theta, you know those always have to do with the x values if they're with that x or the variable that you're using in the problem. And this is going to be our horizontal stretch or compression. And for us to figure out what our period is going to be, which will tell us how much it's stretching or compressing, we're going to do 2 pi, which is the normal period, divided by whatever that b value is. If you'll remember from the beginning of the year when we were determining stretching and compressing horizontally, we always did the reciprocal of the number that was on the inside. That was like September, so you might not remember that, but that's where that's coming from, that 2 pi over b. 2 pi is the normal. We're going to divide it by whatever we have next to our theta. That's going to tell us the size of our period. So normally it's 2 pi. Right? If our period is 1 pi, we have to get a full rotation done before we get to 1 pi. If our period is 4 pi, our full rotation is going to stretch out to be 4 pi long. Okay? So that one thing that we did from sine that was up, down, up, or from cosine that was up, down, up, whatever our period is, that's how long it's going to take us to do that one section of the graph. We're going to find 2 periods first, and then I'll graph them and show you how we can do that. Well, let's go y equals sine 2 theta, and y equals cosine theta over 4. So we first identify what our b value is, what's in front of our theta. Then we plug it into our period formula so we know how long we have to get through one of our rotations. So on our first one, what is the b? 2. Okay, so b equals 2. So to find the period, it's 2 pi over b. It's 2 pi over 2. What's going to happen with our 2's?
Cancel.
They're going to cancel, and our period is pi. So from 0 to pi, we've got to get through our sine rotation. Okay, we'll find the period of this one, and then I'm going to graph both of them. What is the b value on cosine of theta over 4? What is multiplied by theta? What number is understood right here in front of the theta on top of this fraction?
1.
Yeah, so it's theta is multiplied by 1/4, right? If it was just 4, it would just be a 4 theta, but it's multiplied by 1/4. So our b value is 1/4. We have 2 pi divided by 1/4. So when you divide by a fraction, that's the same as multiplying by its reciprocal, right? Flip the second one over. So that's the same as 2 pi times 4 over 1, which is going to equal what? How many pi? 2 pi, yeah, 8 pi, thank you.
8 pi, sorry.
That's okay. So the period of the second one is 8 pi. So it's going to take us from 0 to 8 pi to finish one of our cosine rotations, or one of our sets of cosine. Okay, so let's graph our sine first. And I put the numbers on the x-axis based on what my period is. So I know I'm going to start at 0 and I need to be finished by pi. Then I'm going to fill the rest in. What is the halfway between 0 and pi? That's going to be pi over 2, right? If y'all want, we could just go ahead and graph it right now. You want to? Okay, so this is sine. Where are we starting? At 0. We also finish at 0, and our middle number is 0. Everybody okay with that? The first, the end, and the middle, those are all 0 on sine if you go back up and look. Oh, I'm not cosine. Here, 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 okay? And then halfway between our first 2 points is at 1. And halfway between the second two, or the second and third, is at -1. So I'll just plot halfway between at 1, halfway between at -1. So we start at 0, we finish it by pi, so that has shrunk it. We have a compression here. Normally it would be 2 pi long, now it's 1 pi long.
Why would we have the ones or plot the ones? A 1 and -1?
Because you need to have the shape of the graph.
Okay.
It still needs to be the same shape, it's just shrunk. If you wanted to be exact and go through and put that this is going to be pi over 4, because that's halfway between, and that's 3 pi over 4, you can, but it just gets kind of crowded. If you just have these 3 points, you just know halfway between is up, halfway between is down there. So we always have that shape for sine. Now we'll do our cosine graph. How long is this? Do we need to make this for cosine?
8 pi.
We need to make it 8 pi. I'm going to go ahead and do a halfway point as well. Halfway between 0 and 8 is how many pi? Yep, 4 pi. And think about cosine. Where does it begin? Begins and ends at 1. Its middle number is at -1. So cosine begins and ends at 1. Its middle is at -1. So I'll scroll back down a second, drawing the same shape that we had. Begins and ends at 1, middle's at -1. And in between those is where we cross the x-axis. Cross halfway, cross halfway. So now instead of being done by 2 pi, this is what a normal sine would be, done at 2 pi. We've stretched it out, normal cosine. We've stretched it out to an entire 8 pi. So that would be a horizontal stretch, or a period of 8 pi is another way to say that. Okay, so 2 pi over b gives you your period. It tells you where we start and where we end. Any questions on amplitude and period? Nope. Okay. The next kind, these are called phase shifts. Phase shift is a fancy way to say a horizontal shift. What variable do I use H? So if you have a number that's added or subtracted with your x or theta, whichever variable we're using, doesn't matter. Let's all be consistent, use theta the whole time. So this is our horizontal shift. Remember, a plus sign means you're going to the left, a minus sign to the right. So the same thing that we've always done if it's in parentheses. Plus is to the left, a minus is to the right. Cosine. So for these, we're just taking the whole graph. We're not changing the period or anything. We're just shifting it left or shifting it right, depending upon if it's a positive or negative. And the number after tells us how much we shifted in either direction. So our first one says sine theta minus pi over 2. So are we going to the left or to the right? We're going to the right, and we're going to the right pi over 2 units. So it has a phase shift of pi over 2 to the right. So this is what I do when I draw these, just because I don't like to have to think about doing it. I just draw a regular one, and then I literally try and shift it pi over 2. So a regular one is between 0 and 2 pi. Here's my pi. But these are all, I mean, you're doing it on CUDA, so it's going to be multiple choice. So you're just going to make sure that you have got it shifted appropriately. So this one's normal, if I hit all the points right. So y'all agree that's a normal sine curve?
Yes.
Okay, so I'm just going to take it and move it pi over 2 over. So that's pi over 2 is this much. So I just take my whole graph, move it over pi over 2. I'll make the dots follow it.
So I have a question. So if it was like theta minus 3 pi over 2, would you like take those 3 points and
If you would do minus 3 pi over 2, you would take your graph. You're going over 1, 2, 3 pi over 2. And that's where it's going to start. And you have to think about it because the graphs that you're going to see are going to be drawn all the way throughout. So you just have to look and say, okay, that's where it would normally start. But now that section has got to be here for pi over 2. Or if it was 3 pi over 2, it's got to be right there. So you're going to identify your group, your first group, and see if it starts on the right point. Okay? You're seeing where does that origin point start if you've got a lot of points. Where does that one go? Did I just put a random point somewhere? There you go. So that was shifted over pi over 2, but you will have the rest of the graph drawn on there as well. So it'll look like this. It'll still be going, but you just have to see it normally started here. Now it's shifted over that much. Now for our other one, which way are we going to go? To the left, and we're going to the left, pi over 4. So cosine starts up at 1, ends at 1, middle is -1, 0, 0, connect. And we are shifting pi over 4, which is halfway between 0 and pi over 2, right? That's just like 45 degrees. So we're not going all the way to this negative pi over 2. We're just going halfway there. Trying to get that right there. So all of my points got shifted pi over 4 to the left. So halfway between 0 and pi over 2. Aisha, is your sister learning trig today?
That's my little cousin. She was telling me she was telling me something about the dogs.
I thought she just wanted to know about trigonometry. Advanced for her age. So those are phase shifts. They either go left or right. You just have to identify where it is in the picture. Hey, and the last one, these are vertical shifts. They don't have a special name. That's just moving the whole thing up or down. When you have a number added at the end, or it could be added at the beginning if sometimes they put them there. So it's separated by a plus sign or by a minus sign. That's going to be a vertical shift. You're just taking the whole thing and moving it up and down. So sine theta plus 3, we're taking a sine graph and we're moving it up how many units? 3, you're taking the entire graph and moving it up 3 units. We're not changing the size of it, the amplitude. We're not shifting it any other way. It's just the normal one. It's now going to be, everything's going to be 3 units above where it was previously. I'll just do those two if you want. No, I'll do all of them. If I'm going up 3 units, how many tick marks do I need on my x-axis at least? I need 4. Okay. 2, 3, 4. And this is how I draw them if I'm drawing them by hand, which y'all don't have to really draw them by hand. What I do is I think I'm shifting the whole graph up 3 units, so it would be nice if I could have like a kind of like a fake x-axis 3 units up, because I'm normally base things on this is on the x-axis, this is on the x-axis, and this is. So this isn't an asymptote. This is just 3 units up. I kind of draw like a dotted line to know I'm going to shift it this much. And then I just put my points like normal. So I pretend like this is my x-axis, just in my fake head. And sine graphs go 0, 0, 0, 1 up from that, and 1 down from that. It looks really narrow just because my tick marks are small. I need to try that again. So this has every point shifted 3 units from where it was. Normally it's at 0, then it's at 3. Normally it would be at 1, but that's at 4, 0, 3, negative 1, 2, 0, goes up to 3. But instead of having to put all your points and then add 3 to each of them, if you just think, okay, this would be where it would be if I shifted it up, you can still do your pattern. At the zeros, 1 up, 1 down. All right, we'll do one more example, and then you guys will have 30 minutes to work. And it's just really, this is all multiple choice for you guys. It shouldn't be too much. You're not having to hand sketch them, which is.
So do we actually need the unit circle?
No.
Okay.
We just needed it to get the point so you would know what the graph looked like. Yeah. Well, once you know the shape, you don't have to use it over and over.
So you want us to find like the amplitude and the period for all of them, like write them down?
Yeah, the ones for the period, I'll have you write those down because you have to do that dividing. So you'll need to write that part down. But most of the other, if it just says find amplitude, that's just the number in the front. You don't need to write that down.
All right, but
okay. All right, so one last problem. Let's go. I'm going to do a combo. So we're going to do a amplitude, a vertical shift, and that's all. I don't think I'm going to make it upside down or anything for you. So let's go. Let's say I had 2 cosine theta minus 4. So this has an amplitude of 2. It's a cosine graph, and it's shifted down 4 units. I needed to make 6 tick marks down because if I'm shifting it down 4 units, I'm still going to have to go up 2 and down 2 from that. So I need to be at least -6 for that lowest point. Okay. So since I'm going down 4, I'm going to make like my fake x-axis at -4. That's where the center is going to be. And cosine is normally starting and ending at 1, but this one won't start and end at 1 above it. It's going to start and end at how much above our line? because of the amplitude. Amplitude is 2, so we're going to go from our line that we drew 2 above, and the center is 2 below. Zeros at our halfways. And then you always want to double check. Is this a cosine shape? Does it start and end at 2 pi? Is the amplitude 2? And is it shifted 4 units down? Yep, then you are good to go. What's the minimum value? -6. What's the maximum value? -2. So the only ones you have to write down on here are the period problems. I don't think there's anything else that you need to do.